Dear friends, welcome to my video lecture series. This is your Balaganishan. In this video, we are going to analyze hyperbolic kind partial differential equations. Are you ready for that? Yes, come to the topic, hyperbolic equations. So how to identify this hyperbolic kind? So they have given the differential equation. We have to find the value of A, B, and C. Find b square minus 4ac. If we're getting positive greater than 0 or positive, we can conclude that it is hyperbolic kind. Okay, fine. So what is your capital E? The a square, second derivative with respect to x, b values 0 and c values -1. So b square minus 4ac is 4a square, it is positive, so it is hyperbolic kind. And this is a familiar one. Already you discussed the same topic in the previous semester. One-dimensional wave equation. One-dimensional wave equation is the one kind of hyperbolic equation. So that one only we are going to classify. Right. Our aim is to find the solution for one-dimensional wave equation. You know very well, in one-dimensional wave equation, how many boundary conditions will be there? Always I will use to give the clue like that. This is second order. This also second order. So totally 2 plus 2, four conditions will be there. Boundary and initial condition will be there. Totally four. Suppose u double x equivalent to a into ut. The one-dimensional heat already we discussed. How many will be? This is second order. This is first order. So totally three conditions will be there, including initial and boundary. Clear? Right. Now this is also second order. This also second order. Totally four boundary condition. Look at that. 1, 2, 3, 4 conditions. These two are boundary condition, these two are initial condition. So initial velocity ut, dou u by dou t. Initial velocity is 0 here. Right. Now we are going to use different quotient concept. U double x equal to this, and similarly u double t is equal to this. If you are substituting in the above equation, we will get this equation. Then our aim is to find the simplified form. Here we are taking LCM, and finally we get this. Here lambda equal to k by h. Then the final equation 1 is going to call explicit scheme for one-dimensional wave equation. They will ask for MCQ. Even if you want to write in the easiest way, the equation 1, we are going to give this value as 0. 1 minus lambda square a square equal to 0 to simplify the equation. So we are going to give the simpler form. If you want to get the simpler form, we are going to give 1 minus lambda square a square equal to 0, which implies lambda square is 1 by a square, which is equivalent to what is lambda square? K square by h square. From this one only, we are deriving k equal to h by a. This will be important one, you know very well, because already we discussed several topics in this unit. In x direction will be h, in t direction the difference will be k. So we have to find the value of k. So this will be important number, k equal to h by a, right? Then the simplest form of the one-dimensional wave equation, explicit formula. One-dimensional explicit formula is equation 2, this one only. The graphical representation for that one is, so this is what our value we have to find. Then it will be b plus c, straight line we have given. If you're getting any confusion, you can draw like that. A equivalent to b plus c minus d. Here it is minus. Here it is plus. B plus c minus d. That's not the above value, previous the top of the above value. Clear? This is what the graphical representation for the explicit formula of second order partial differential equation. Particularly, we will call it as one-dimensional wave equation. Okay, fine. Now, another one concept also there. Additionally, previous that and all, you don't have another derivative. Here we have in the boundary condition itself, one velocity function is there. Ut of x comma 0, initial velocity is 0. For that, we have to derive one formula. That one only they are doing here. So if they are proceeding like that, they can get this formula u of I comma 1. What is I comma 1 represents? Right hand side, this will be Bender-Smith formula, average, where we have to apply u of I comma 1. What is I comma 1 represents? X value is I, t value is 1. Wherever the t value 1, we are going to get t value 1 means the first position value, t equal to first time step. In that position, we have to apply this formula. While I am explaining the problem, I will tell you what you have to do there, then only easily you can understand. So, the important thing is already we have one explicit formula, graphical representation for that, and another concept will be there for you because we are having initial velocity, it is there. For that also, you have one formula. That is the important thing here, right? Convergence of hyperbolic equation. When it will converge? Hyperbolic equation is nothing but one-dimensional wave equation. When it will converge, it should be, look at that, they have given. The solution is stable if lambda equal to 1 by a. Suppose if lambda greater than 1 by a, it is unstable. If by h, ka by h is nothing but lambda. That value is equivalent to 1, then the solution is stable. That means this one only. Then if Ka by H is less than 1, the solution is stable only, but the accuracy will decrease according to the Ak by H value. If it is decreases, then accuracy also will decrease. That is only for lambda equal to 1 by A, the solution is stable. Clear? That's it, guys. They may ask for MCQs, that will be important. I have chosen one problem here. Solve numerically. U double x equal to ut. This is the clue to identify. A into u double x equivalent to u double t. Clear? Both are second derivatives. Second derivative with respect to x, second derivative with respect to y will be Laplace equation. This is the clue to identify. And another clue will be how many boundary condition will be there in Laplace equation also. There will be four boundary condition, but a u suffix to initial velocity won't be there. If initial velocity, if it is coming in the boundary condition, then it will be a one-dimensional wave. That is another clue, right? Boundary condition and initial condition they have given uh, with a special step h is equivalent to 1. In x direction, h equal to 1 for 4 seconds. 4 seconds means what? T equal to 4. 4 times step means it will be x up to 0, first time step, second step, third time step, fourth time step. In that way it will move. So here time t equal to 4, right? Choose the question a square. What is the given differential equation? A square into u double x. Previously I have written a, I think so it is a square equivalent to u double t. So what is the value of a square? It is 4. Then h value he has given. K equal to h by a. Positive value only. A square equal to 4. A equal to plus or minus 2 will come. We won't take the negative value there. So k equal to h by a will be 1 by 2. K value 1 by 2. In t direction, difference will be 1 by 2. X direction, difference will be 1. Clear? That's it. Use the formula. You have no need to confuse with the formula. Just remember the diagrammatic representation. What is the diagrammatic representation for that? This one only. If you want to find this plus this minus of this. Clear, right? So if you apply the diagrammatic representation, we can solve this problem easily. And another one formula will be there for ut of x comma 0. What it is? U of I comma 1. At t equal to 1, we have to apply this formula. Mm. So what it is? It's look like Bender-Smith method. I plus 1 comma 0, I minus average of the two value. Right. So we are going to find the interior values now. These are all the given boundary conditions. In x direction, h equal to 1. In t direction, k equal to 1 by 2. Now, listen now. H equal to 1, x varying from 0 to 4. So 0, 1, 2, 3, 4. Difference is 1. Similarly, what about up to t equal to 4, t equal to 4 seconds, we have to find difference is what? 0.5. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4 up to t equal to 4. Now we have to write the boundary conditions. What are the boundary conditions? At x equal to 0, u value is 0. So everything will be 0, 0, 0, 0, 0. And at x equal to 4, this is the second boundary condition. At x equal to 4 also, u value 0. So everything will be 0, 0, 0, 0, 0. Okay, fine. Now the third boundary condition, u of x comma 0. X comma 0 means t equal to 0 line, t equal to 0. This one. So x into 4 minus x. Give x 0, it will be 0. Give x equal to 1, it is 3. Give x equal to 2, it will be 4. Give x equal to, it will be 4. 2 after 2, it will be 3. If you're giving, it will be 3 into 1, it will be 3. If you're giving x equal to 4, it will be 0. As I told you already, the corner value should coincide. Now we have to find the interior points. As I told you already, this is a t equal to initial position. This is t equal to 1 position. 0, 1, 2, 3, it will be like that, and not the value 0.5 that and all going to give. T equal to first time step position. This is initial time step, first time step, t equal to 1. That is what the meaning here. First time test step position, we have to apply that average formula. What is the average formula here? Will you tell me that formula? Yeah, as I told you already, it's look like Bender-Smith formula. So the boundary condition, everything we have completed. This one I have to find. What is according to Bender-Smith? This plus this by 2, it will be 2. Similarly, if I want to find this plus this by 2 will be 3. Similarly, if I want to find this plus this divided by 2, it will be 2. Clear? So only for this step, t equal to 1 step. The only for this position, you have to apply that Bender-Smith formula. Right. It's look like Bender-Smith formula. Do not confuse. We are applying Bender-Smith formula here. So average of the two value. Right. What about thereafter? 2, 3, 2 we found because the average of that average. This, this average, this average. Now we have to find this value. How to find it? Would you remember the diagrammatic representation? I will show you again. So this one. If I want to find this value, this plus this minus of this. So B plus C minus D if you want to find the value. Now look at the diagram position. I have to find this. So what I have to find? This plus this minus this. Clear? I hope easily you can understand now. So this plus this minus of this. So 0 plus 3 minus 3 will be 0. Now next I have to find this position only. This plus this minus this. So 2 plus 2 minus 4 will be 0. Next I have to find this position value. 3 plus 0 minus 3 will be again it will be 0. Clear? Right. Now I have to find this position in the proceeding in the similar way. Only first time step position only you have to apply Bender-Smith concept. Apart from that, the hyperbolic equation, I mean one-dimensional wave equation diagrammatic representation only you have to use. If I want to find this, what will be this plus this minus of 2. So it will be minus 2 will come here. Look at that. 0, 0, 0. So how to get minus 2? This plus this minus of this. Clear? Right. So I have to find the next value. How to do that? This plus this minus of this. Similarly, how to get minus 2? 0 plus 0 minus 2. Similarly, proceed for the other steps also. We can find the answer. I will explain here too. 3 plus 3 minus 0 will be 3. 2 plus 2 minus 0 will be 4. 3 plus 0 minus 3 is 3. That's it, guys. This is the way you have to solve the problems in hyperbolic kind. I mean, one-dimensional wave equation. I have chosen one more problem here. A square u double x equivalent to ut, and the boundary condition u of 0 comma t 0 5 comma t 0 ut. This is the clue, as I told you already. Using equation we can identify which kind is this, and velocity function u suffix t of x comma 0 equal to 0 is also there, and u of x comma 0 equivalent to, so they have splitted into two functions. That's why particularly I have chosen this problem also to explain here. Right. Now come to the problem. For 1/2 period of vibration, that is the important thing, guys. It is not 1 1/2. 1/2 means full length will be there. 1/2, half period of vibration, because it is a vibration of a string. Could you remember the previous semester? A string of length L stretched and fixed into 2 points A, B, and then you will disturb the string. It will vibrate. That displacement function only, the vibration of the string only, uh, you found analytically there. Now we are proceeding here numerically. So 1/2 means only half, 1 1/2 only, it will be 1.5. Clear? So period of vibration, you should know that formula that I will give you here. First to find a square, a equal to 5, then k equal to, what is the formula? K equal to h by a is equivalent to, what is the value of h? Did they specify anything? Yes. Did they specify anything or not? Where it's varying from where to where? 0 to 5. It is going to vary. So they have to mention that value. H is equivalent to, they didn't specify here. If they're not specifying here, you can consider that is let H is equivalent to 1, because 0 to 5 it's varying. So 1, 2, 3, 4, 5 it will be easy. If you're taking 0.5, it will be fine. 0.5, 1, 1.52 will be very lengthiest one. Okay, the maximum they will specify. If they're not specifying, you can take H equal to. H equal to 1 means 1 by 5. 1 by 5. It is 0.2. K value over. Okay, fine. And we know the H value and the K value difference up to how much time, up to how much seconds we have to find the interior temperature value. Sorry, here not the temperature, the vibration of the displacement of the string. Right. So this was the formula. Period of vibration 2L by A. 2L upon A will be period of vibration. But what do you have to find? Half of period, 1/2, not 1 1/2. 1/2 period of vibration we have to find. Right. So period of vibration is 2L by A. What does L means? X equal to 0, X equal to L. This is what the thing. Yeah, a string of length L. So what he has given here? It is varying from 0 to 5. X equal to 0, X equal to 5. So the length will be L, 5. So 2 into 5 divided by A value, it's here using the differential equation, you can find it. So it will be 2 seconds. So the period of vibration is 2 seconds. Then what about half period? Up to 1 second. T equal to 1, we have to find. Up to T equal to 1, we have to. Instead of giving a time duration directly, they have given 1/2 period of vibration. Is it clear? Right. That's it. So therefore, we have to find up to T equal to 1. What about key value? It is 0.2 difference. Now come to that point. Formula will be here. You no need to confuse with the formula. Try to remember the diagrammatic representation. What is the diagrammatic representation? This one only. B plus C minus D. So we have to find the interior values of U given. These are the boundary and initial conditions. Boundary conditions and initial conditions are there. Right. In x direction, h equal to 1. T direction, k equal to 0.2. So x varying from 0 to 5, 0, 1, 2, 3, etc. 5. K up to t equal to 1. We have to find what will be the difference? It will be 0.2, 0.2, 0.4, 0.6, 0.8, 1. So what is the first boundary condition? U value 0 at x equal to 0. 0, 0, 0, 0, 0, 0. What is the next one? U value 0 at x equal to 5. 0, 0, 0, 0, 0, 0. What is the next one? This one you can do for the first time step. For this step only you can do this. You can do this, not in this place. Another one boundary condition will be there x comma 0 that will satisfy this one. X comma 0, t value 0, t value 0 position is this. Am I right? Right. Now give the values x equal to 0. Where you have to give 0 means 0 to 0.425 here only. Including 0, including 2.5. Here including 2.5, including 5. The function is going to vary. Give x equal to 0, 2 into 0 will be 0. So it will coincide. And then give x equal to 1. So giving x equal to 1, where it will be? This position will be, it is 2. Give x equal to 2. So giving x equal to 2, what will happen? 2 into 2, 4, this place only. So it will be 2 into 2, 4. Give x equal to 3. You can't be able to substitute here. X equal to 3 will fall in this interval only. So give x equal to 3 here. 10 minus 2 into 3, 6. It will be 10. And finally, x is equivalent to what do you have to give? X equal to 4. X equal to 4 will be in this in this place. We're giving x equal to 4 here. 10 minus 8. What will be? It will be 2. X equal to 5. Give it 5 into 2 will be 10 minus 10, 0. So the common value should coincide. That's it. We found the boundary values. Now we have to find the interior lattice points. So how to do the first time step? First time step. It will be average of this and this. 2. Again 3. Again. Again this will be, so 4 plus 2 divided by 2 will be 3. Again 4 plus 0 divided by 2 will be 2. The first time step only. First time means not a first place. Beginning one is initial time step, first time step. So we have to apply Bender-Smith formula. Average of the two. Find thereafter, if you want to find this value, this plus this minus this. Clear? Fine. I have to find this. This plus this minus this. So 2 plus 3 is 5. 5 minus 4, it is 1. Similarly, 3 plus 2, 5 minus 4, 1. and then similarly try to do all the steps. Continue in the proceed in the similar. How you are getting -1 here? What will be 0? Whatever in the place, it will be not here. This one we have to find. So 0 plus 1 minus 2. It will be -1. Similarly, proceed for everything. You can get the interior point values. That's it, guys. This is the way to solve the one-dimensional wave equation. Particularly, if you want to call it as what it is, the hyperbolic equations. Clear? So I have given the clear-cut idea, clear-cut diagrammatic representation, and in the table also I have given different colors for understanding purpose. I hope it will be easy to understand. If it is easy for you, just like it, share to your friends, and then subscribe it. Thanks for watching my videos. Thank you.